Hi, today I want to show you how to use CATIP, the AutoML tool or the hyperparameter optimizer in Kubeflow. So hyperparameter optimization can be used for normal algorithms, like for example parameters in gradient boosted trees or so, but also in neural networks. And if you also change the architecture or shape of the neural networks, for example number of layers and neurons and activation functions and so on, you are already entering the domain of neural architecture search. So I will show you the UI. There is obviously also an API version of it, where you can interact with using Python or YAML files. But here we are in Kubeflow. I've already explained how to install this in another video on my channel. And what you need to do is you click on experiments and you say a new experiment. And then here you have a lot of choices. I will show you a little trick how to get this done faster. So you need to name it, and then you have to tell how many trials you want to run in parallel. That depends on the size of your cluster. If you have some sort of a cloud auto-scaling Kubernetes cluster, obviously you can increase that number without increasing the cost, because the runtime gets shorter and the parallelization gets higher. Here in objective you need to tell what metric you want to maximize. For example, here validation accuracy. Then search algorithm, that's the most interesting one. So I will cover those in a separate video. Here let's take just random and crit for now. So random obviously searches, that's some sort of Monte Carlo optimization. No? You search through the hyperparameter space by just picking random values for all the hyperparameter dimensions, and in grid search you kind of visit each point in that hyperparameter space one by one. Obviously also in parallel, depending on your parallelization here. And the others I will just cover in another video, okay? And it's something I have to announce. So I've requested population-based training from the Kubeflow team, and actually someone created a PR for it, so it will be in soon. So PBT is basically a genetic algorithm, so very keen how this performs. You can then also define early stopping, so you don't traverse the whole tree, you just stop at some branches if they are not promising. Then those are the hyperparameters you actually want to search over. So if you do manual grid search, then this is basically the initialization of the nested for loop. No, those are the parameter ranges, here the types, and here the ranges. You see here also optimizer here. Those are different stochastic gradient descent variants you are trying out and so on. I mean that's the usual stuff. The only thing here what CATIP provides to you is to run this in a nice UI on Kubernetes, and you can parallelize and just also creating a nice UI for you later. I will show that to you. Yeah, so that's most of it. And then I told you there's a little trick. You can just edit the YAML, and I have here a YAML file actually expressing such an experiment. And the thing which is very interesting to notice here is the actual training is defined by you. So you have to provide a container image where your training takes place, and also the command which is then run in your container. So it's very basic, let's say Docker stuff. No, it's not rocket science. And those are then the three hyperparameters passed to your Python script in this case. So it's very, very down to earth. No, and obviously it's not running here in parallel. No, so there are multiple trials obviously running in parallel, but the actual training is running in a single pod. That's something to notice. Not sure whether you can integrate a TF job operator in here or not. That's something I need to find out. Anyway, you can just take this whole YAML file and then paste it here, and then everything is already oh, I'm in the wrong namespace. Anyway, everything will then be filled out for you already, so that's pretty cool. And I've already prepared such a run for you and let it run. So this is this one here. And what you see here, that's maybe a little confusing. Let me just explain this chart here. You see here the target, that's validation accuracy. And obviously training accuracy is also something you might be interested in, and you can then just follow the lines. So the high validation accuracy line here is indicating that you, for example, have a learning rate in that range here and a small number of layers and the Adam optimizer. Anyway, Adam, or all the optimizer or all the stochastic gradient descent optimizer variants which start with R, A stands with A stands for adaptive, are changing the learning rate over time, and usually they are the most powerful at the moment. So this is very confusing if you have a lot of trials here. I have here also posted some screenshots while this was ramping up. So while this was ramping up, it's much more clear to see what's happening. So that was right in the beginning phase, and later on, obviously this is getting more and more busy. Until you see that one. Therefore, you have here a table with the trials where you can basically see here validation accuracy, that's your target, and then you see which hyperparameters have been chosen for that trial. That's all for now. Have fun, and yeah, I will explain you the different optimization algorithms in more detail, and obviously also I will dive into neural network architecture search soon. Okay, stay tuned, all the best, bye.